Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 13, the Roman to integer challenge. This is a foundational string manipulation problem frequently asked in interviews at top tech giants like Google, Amazon, and Microsoft. Let us look at the problem statement. Our task is to convert a Roman numeral string into its integer representation. We have 7 core symbols: I, V, X, L, C, D, and M. Most of the time, we simply add these values together from left to right. But, as we know, there are special cases where subtraction is used, like 4 being written as IV instead of 4 ones. Think of the challenge here. If we just add every symbol, we will get the wrong total for numbers like 9 or 40. We need a way to detect when a smaller symbol is acting as a subtractor for the larger one following it. To solve this in O of n time, we use our golden rule. The look-ahead strategy. Imagine you are a translator reading an ancient scroll. You look at one symbol at a time, but you always keep one eye on the symbol immediately to the right. If the current symbol is smaller than the next one, it means you are in a subtraction zone. You subtract the current value from your total. Otherwise, you simply add it. It is like seeing a $1 off coupon right before a $5 price tag. You know the final cost is 4. Now, let us dive into the dry run. This is the most important part. Look at the screen. We have our Roman string MCMXCIV at the top, and our result tracker at the bottom. Notice the caption box updating as we move our pointer. First, we look at M. Its value is 1000. The next symbol is C, which is 100. Since 1000 is greater than 100, we simply add it to our total. Result is now 1000. Next, we move to C. Wait, look at the next symbol, it is another M. Since 100 is less than 1000, we are in a subtraction zone. We subtract 100 from our total. The result becomes 900. Now look at X. It is followed by C. Again, 10 is less than 100, so we subtract 10. Finally, we reach I, followed by V. 1 is less than 5, so we subtract 1. We add the final V, and our total is 1994. The look-ahead rule handled every case perfectly. Now that we have walked through the logic visually, let us see how this translates into our Python code. We start by defining a dictionary called Roman, mapping each symbol to its integer value. We initialize our result variable to 0. We then use a simple loop to iterate through the string up to the second to last character. Inside the loop, we check our golden rule. If the value of the current character is less than the next one, we subtract it from res. Otherwise, we add it. Finally, we add the value of the very last character. Why? Because there is no next character to compare it to, so it always acts as an addition. This keeps our code clean and avoids out-of-bounds errors. Looking at the complexity, the time complexity is O of n, where n is the length of the string. We only pass through the input once. The space complexity is O of 1, because our dictionary always has exactly 7 entries, no matter how long the input string is. And that is the Roman to integer challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more 10x premium DSA guides. Send this to a friend who is prepping for their big tech interviews.